So thank you so much, Rachel. And thank you everyone for being here tonight. Spring allergies are definitely getting to me, so I apologize if I start to lose my voice, but I have my tea at the ready. So tonight I am going to share with you some results, some preliminary results of the before and after dam removal fish passage evaluation. So as Rachel said, this was going to be an in-person talk back in March 12th. And it was funny when I went to my computer to start working on a Zoom version of this presentation, my computer asked me, do you want to pick up where you left off on March 12th? I thought, well, yeah, boy, the world has changed a lot since March 12th. So I said yes. So the question some of you might have found in the chat box already was, what was the first river herring run that you visited and how old you were? And I loved reading people's answers. It was fun to see that some people visited them when they were very young, and some people just found river herring as adults. So I'll answer that question for myself. It was either the Back River in Weymouth in Jackson Square, or this herring run that I'm showing you a picture of right now is the Stony Brook run in Brewster. And so I am about 4 or 5 maybe, I think, and then that's my brother right there, and my mom's got a death grip on his collar to make sure he doesn't fall into the river herring run. And this is how I got interested in river herring. This is just something that my family did in the spring. We visited herring runs. And because of that, I got interested in science, natural history of all kinds, but especially fish. So I am now the fisheries and aquaculture specialist, and I know that's because the adults in my life took the time to take me out in nature, so it had a huge impact on my life. So I work for Woods Hole Sea Grant and also Barnstable County. So Barnstable County is the 15 towns of Cape Cod. I'm a fisheries and aquaculture specialist. And Sea Grant is one of, or Woods Hole Sea Grant is one of 34 Sea Grant programs that are located across the country. Sea Grant was founded in 1966 by Congress. The motto is Science Serving America's Coasts. And basically my job is to work with people who make their living from marine resources or who manage marine resources along our coastlines. So that's folks like shellfish wardens, river herring wardens, natural resources officers. Figure out what kind of problems they're experiencing, what kind of issues they have along the coast, and then figure out how scientific study and monitoring can help them with those questions. So that's partly how I came to be working with Plymouth on this project, but also because way back in 2006, I did my master's degree on Town Brook. So I looked at the removal of the Billington Street Dam, which was the first dam removal on Town Brook, and the first one in Massachusetts that was done specifically to provide better passage for river herring. So this is what it used to look like. And then by the time I arrived on the scene, it was restored. So they removed the dam and then put in what we were calling a nature-like fishway. It was a restored river. And the question was, were herring getting up this new design of fish passage? So, and then we got a publication out of it. So I worked with Dr. Alex Harrow at the United States Geological Survey Conti Anadromous Fish Lab. So it was under his direction that I did this research and we published, and sure enough, so of the fish that we tagged, 94% of them got up through that restored section of river. So I was doing this work that, so that work I did back in 2006 was part of a project that was happening at this wonderful lab. So it's a federal lab. There's an entire lab dedicated to the study of anadromous fish. So sea-run fish. And also eels, so you could say diadromous. So there are 4 labs, so it's located in Turner's Falls, Massachusetts, along the Connecticut River. And there's an ecology lab, physiology, behavior, and then Dr. Alex Harrow is the principal investigator for the fish passage lab. And so as a kid who grew up being fascinated by river herring, it was amazing to work at a lab surrounded by people who also had a passion for these fish. And you could build giant experimental fish ladders in this lab. So there's a big concrete flume, and you could bring in water from the Connecticut River and test out all sorts of different configurations of fish ladders. send fish through, and then see if it works. So they were doing a project on nature-like fish ladders in the lab, and then the work I did in Town Brook, partnering with Town of Plymouth, was the field component of that. So after that research, David Gould and I stayed in touch. We've worked together on other projects. And then when it started looking like there was going to be funding to remove the Holmes Dam, David asked if I would be interested in putting together a team and seeing if we could find some partners to do a study on, this time, not just after the dam removal, but to actually study river herring passage both before the dam removal and then after the dam removal. And thankfully, David was able to secure some funding from our amazing partners, which I will mention in a little bit. And then Dr. Alex Harrow at the USGS Conti Lab was willing to partner on this project as well and lend us quite a bit of equipment. So here's Holmes Dam. If you don't know much about Holmes Dam, I encourage you just type into Google, Holmes Dam, Plymouth, Massachusetts, and you will find a whole bunch of articles about the process and lots of great photos. There were over 30 partners that came together on this project. You can see the major funders across the top of this banner that was on the chain link fence around the construction area. And then the evaluation project was funded through U.S. Fish and Wildlife Service, Town of Plymouth, Sea Grant, USGS, and in some in-kind help with Division of Marine Fisheries. So Holmes Dam, I think you know, is not the only dam removal that's taken place in Plymouth, but I am going to focus just on the Holmes Dam fish ladder, or excuse me, the Holmes Dam area for this talk. If you'd like to learn more about all those other removals, highly encourage you to check out the NOAA story map. So again, if you just, and I can put in links in the chat box later, but if you just type in NOAA Town Brook story map, this beautiful computer story will come up and show you photos and videos and the data that's been collected on the river over the years. So here's the star of our show. This is our alewife, otherwise known as river herring. We're pretty sure that we just have mostly alewife in Town Brook, so maybe some blueback herring, but we know that from Division of Marine Fisheries doing biological sampling. So I'm going to say alewife, or I'm going to say river herring, but I mean the same species of fish. These are our guys and girls. So I often get asked the question, like, why do a before and after dam removal project? Like, of course it's going to work. Why would you do this? So I get a variety of answers. I am very curious to hear from you. So if you find the chat box feature, why do you think, so type in your answer into the chat box, why do you think it might be important to do a before and after dam removal fish passage evaluation? Why would that be worth the time and energy and funding to do? And Rachel, I can't see the chat box with my slides up, so can you, oh, awesome. Thank you.
People are thinking really hard.
Oh, good.
Here we go. To let us know if the money is well spent, to find out how well the removal worked, to see if fish are still using the river to go upstream, to determine if it was successful and able to be replicated.
Yes.
To prove that you're making a difference, good science demands it. To give the fish a medal for going upstream.
Maybe two more?
To see the impact on river species, mammals, otters, etc. And data is always important. Oh, and to support the removal of other dams. I'll throw that one in there. That's important.
Thank you for sharing those. And I cannot wait to read the whole list because I know Rachel didn't get to read all of them. Thank you for all that input. So I think most of my thoughts are in those chat feedback already. So yeah, to make sure it works, there's actually a bunch of examples of restoration projects where things didn't quite work right after it was finished. And because evaluation had happened, they knew to go back and, change some rocks and, make the velocity better and, plug up a leak. So make sure it worked. To actually quantify the information. Some people respond to stories and some people want numbers. So to have those numbers to explain what happened at Town Brook. To learn about river restoration design, I'm hoping one of the speakers that was scheduled to be in person, who is a river restoration engineer, might be able to give us some insight into this too. But just to learn about the designs that are out there and figure out do adjustments need to be made so we keep improving on this. And then to share the information with fellow communities that are considering dam removal. The folks in Plymouth know it's not an easy decision to take down a dam. There's a lot of things to consider. There's a lot of money involved and a lot of time. And so, I'd like to hope that this information can help a community to help weigh the pros and cons of why they might want to remove a dam. So here's an aerial view of that. So thank you everyone for that input. That was awesome. So here's an aerial view of the dam when it was in place. So this was from Google Maps. Let's just say it's 2018 when the dam was in place. So to orient you, I'm going to circle with my little arrow key here. So there's the Jenny Grist Mill. There's the parking lot alongside the Jenny Grist Mill Pond. Here's the little pedestrian bridge. There's that gorgeous, I think it's a magnolia tree right here in the corner. And here is the skate park and the basketball court. And here's Newfield Street. So the dam, Holmes Dam, was 16 feet tall. It was 175 feet long. And then it backed up the river and created this impoundment that was 67 acre-feet large. And it backed up the water all the way up to the Boy Scout Bridge, which is the pedestrian bridge right up around here. So from a fish's point of view, if you needed to, so if you wanted to move upstream and get to Billington Sea, where the spawning pond is, and you want to get past that dam, it's like going through an obstacle course. So I'm going to refer to it as the obstacle course. So you approach here and you need to get upstream. And so this is a spillway with water coming down. You can't really jump up that, but you might try. And then this is the entrance to the first fish ladder, the Steep Pass fish ladder. And that's Mark, one of the Department of Marine Environmental Affairs guys putting together our sensing system. Then after you go through 2 sections of Steep Pass fish ladder underneath Newfield Street, where it's very, very dark, you then have to swim up a 202-foot long denial ladder that has, thankfully, a couple of resting pools in between. And then you go through a short section of pool and weir fish ladder, and then this is where you pop out, maybe exhausted, into the Holmes Dam impoundment, the pond there. And then you have to swim through that mill pond, and then here's the Boy Scout Bridge. And at that point, the river becomes a river again, so it's much narrower than the mill pond is. So our study questions are, did the removal of Holmes Dam improve the passage of river herring? And we wanted to look specifically at that restored section of river. And then also the ultimate goal, did it help them get up to the spawning pond at Billington Sea? And so we used a technology method called passive integrated transponder telemetry, just a mouthful. You may know that is RFID, radio frequency identification. And it's, whether you realize it or not, it's a technology that you are familiar with because it's the same technology that's used for the Easy Pass system, so the toll system on our highways. So this is a gate that you drive through, not swim through. And then if you put this little transponder up on your windshields, and I think they're even a different design now, I think they're just stickers, that's basically a tag. And so when your car drives through, the tag shares its information into this gate here, and then the state knows how much to charge you as you go through. the reason that that tag, the transponder, is releasing its information, sending its information, is because of electromagnetism. So you can't see it, it's invisible, but you're driving through an electromagnetic field. And that happens because if you put electricity through a wire, if you put current through, you get a magnetic field out around it. So to apply that to fish, so here's the Daniil fish ladder, and this right here is a gate, just like the Easy Pass gate. I'm going to refer to it as an antenna. So here's the Daniil baffle, and then this thing over here is a tuning box, and then that's connected to a reader, which is connected to a computer. So there's lots of wires involved in this project. So the fish, as it's swimming through here, if it has a tag, the tag transmits its information. And so here are the baffles. So the guy spent an afternoon making these antennas. So these are the Department of Marine and Environmental Affairs staff, David and Nate and Mike. And so there are wires in this PVC casing, and then it goes all around the baffle, and then that baffle went into the fish ladder. You can also make an antenna across the river. So we call it a full stream antenna. And so this is actually a loop of wire that's held down by rocks down at the bottom. And so then the fish can swim through that. This is what the data looks like. So you tag the fish. Let's see if I can hold this up with this tiny tag. It's 23 millimeters long. And each tag has a unique number in it. And there's a little capacitor in there. So when it goes through the electromagnetic fields, it charges the capacitor, and then the tag sends its data. And then this is what comes up on the computer screen. So this is the 3, that's the antenna number. And then this number in the middle is the tag number. And then the number over on the right is the date and the time in a weird format. So I just convert it later. So how do you actually quantify improved fish passage? How do you actually know that something is improved? So there's 4 metrics that we look at. So the first is attraction, and I'm going to try and show you a couple of animations here. So attraction, the question is, of the fish that approached the fish ladder, how many of them actually entered? So we have here 10 fish that are ready to move upstream, and 4 of them went into the fish ladder. And then this 5th one checked it out, but he decided he didn't like it. So in this case, our attraction efficiency is 50%. So we had 10 fish available. 5 of them actually checked out the fish ladder, even though 1 went this way. So you had 50% that found the fish ladder, basically. The next metric is percent passage. So basically how many made it through. So again, if you've got 10 fish, of those that entered the fish ladder, how many completed the fish ladder? So here we have all 10 fish tried, 6 of them got stuck in the ladder, 4 of them made it. So then you would have a percent passage of 40%. Third metric out of 4 is passage attempts. So did fish try once and succeed, or did they have to keep trying and get delayed as they're going through? So this little fishy made it on his first try, so we consider him successful. So you'll hear me talk about successful fish. This fish made 1, 2, 3 tries to get up. And so in this case, he was successful on his 3rd attempt. We also consider him successful, even though it took him a few more tries. And then the last one is transit time, pretty basic. How long did it take him? So when they go through each of those antennas, there's a timestamp. So we know this guy or girl, we'll just say entered the fish ladder this morning at 8 a.m. So we have a timestamp. And then we know that it went through the antenna at the top of the fish ladder at 8:05. So just do subtraction, and you know it took 5 minutes for that fish to complete the ladder. So here is our experimental setup with, so this is where the antennas were. So here's the dam. This is that 202-foot long Daniil fish ladder. You have to imagine that there's 2 steep pass fish ladders underneath the street. And then this is where the beginning of that fish ladder is, the steep pass. And antenna 1 is considered our approach antenna. So this is where we know any fish that got to that point is trying, we're assuming that they are trying to get upstream. So we captured our fish below Jenny Grist Mill, so much further down the river, because as you know, that's a place where fish stack up, so they're pretty easy to capture at that point, although it still requires a lot of people to capture them. So Division of Marine Fisheries lent us their seine nets, and we had a number of interns and volunteers come out to help us. And so you gather up the fish, and then you put them in a fish basket right there. And so that way they're contained, but there's still water moving through the basket so that they can still get oxygen. And now I'm going to attempt to show a video of how the tagging process works. So that's the length. And then I've got a scalpel, so I'm brushing away a few scales. I pick up the tag, then I know what number it's at, and then I push it in. And then at that point, you're supposed to tell if it's a male or a female, but in that particular one, my helper was not sure if it was a male or female. And this brown thing here is a fish board, so there's a ruler on the back of it, so you can see how long the fish are. So for each tag number, we have associated data about how long that fish was, what day it was tagged, and whether it was male or female. It takes so many people to do this tagging. So this is from me down in the river looking up at the crew of people that's helping. So everybody, just about everybody here in waders helped capture the fish. Then Mark and Mike were moving the fish upstream. Kim was our public information officer that day because it's a well-traveled path. So anybody who walked by wanted to know what we were doing. So she would explain and answer people's questions. And then Margie here was our data taker for most of the season last year. So as I'm calling out numbers, she's writing them down and then keeping me on track to make sure the numbers are in sequence. We didn't want to release the fish right below Jenny Grist Mill because, as you know, fish stack up there. We wanted to make sure that they actually got up to Newfield Street. So we put them in buckets and we had little bubblers, and then we gave them a trip, a free ride around that first fish ladder. And then released them right by the Willard Place cul-de-sac. So now we actually get to data. So here are the results before the dam removal. So this is 2018. So, and you are familiar with the metrics now, so we'll start with each of those metrics. So attraction efficiency, 89%, which actually was surprisingly good. I should have put a picture in here. But remember, the fish sort of had a choice. They could enter the fish ladder on the left, or they could get tied up in the spillway on the right. Most of them found the fish ladder. So we released 312 fish here. 299 of them decided to, like, let's move upstream. Let's do it. So they got detected in antenna 1. And then 269 fish were detected at the beginning of the fish ladder. So they found it. So 89%, not bad. Here's the rough number. So of the 269 fish that made an attempt to get through this obstacle course, only 67 of them made it to the top. So that's a passage efficiency of 25%. So these numbers that I put up here in parentheses, I'll only refer to it right now, but this is just to remind us that 25%, that is not the truth, that is an estimate. Based on the number of fish that we could tag. So using a binomial estimate, you could figure out 95% confidence intervals. So we are fairly confident that the actual percentage of fish got through was somewhere between 19.9% and 30.5%. And then I'll tell you the estimate in the middle. So that's what those numbers are. So we also looked at attempts. So it took successful fish, those 67 fish that made it to the top, it took them between 1 and 9 attempts to make it to the top. 50% of them, 50, were successful on their first try. About 16% of them were successful on their second try, and then the rest made between 3 and 9 attempts. And then transit time. So in this figure, down at the bottom, this is transit time in hours. So here's 24 hours, so that's the 1 day mark. And then on the left here is the number of fish that got through in that period of time. So these are like little bins. So the fastest fish made it through in 30 minutes. The slowest fish, it took 28.8 hours, so over a day. The median was 1.9 hours, and the average was 4 hours. So we're measuring the average transit time through in hours. All right, so this is our transition point. So that was all the before data, or before dam removal data. And then we're going to move on to after dam removal. But I'm going to pause here to see if anyone has any questions about what they've heard so far. And I'll defer to Rachel on what form those questions should be taken.
Excellent. So I'm going to ask some of the questions that have come up in the chat that are pertinent to what you just talked about, and then we can save some of the others for the end, if that's okay with everybody. So some people want to know what happened to the fish that don't make it.
What happened to the fish who don't make it? So we can figure part of that out. So I said preliminary data analysis because there's so much data to go through. And so I've been looking at the main questions, but there's all sorts of other ones. So the fish that did not get through, either they might have gotten eaten somewhere along the way by a bird or mammal. They may have decided to spawn in the Jenny Grist mill pond, or they may have decided to just head back out to the ocean and wait until next year.
All right. Do you know what percentage of fish get eaten by predators, such as hungry osprey?
You know, we don't, and that would be a difficult thing to study. You gotta think about that. How would you actually get at that? But no, I do not know that answer.
Okay, we have one here. What makes a herring more successful than others in getting up right away compared to its slower friends? Is there any data on that?
Good question. Eventually, I don't know. Eventually, I will go through and look at those 4 metrics, and then I'll see if there's a difference between males and females, and I'll see if there's a difference in size, and if there was a difference in water level or water temperature when it happened. But just like people, there's variation in fish. Like, we don't all do things the same way for all sorts of various reasons, because of external things and also because of internal things. So fish are the same. They don't all do things the same way.
Awesome. All right, someone has a question about factors that you held constant for before and after data. Are you going to address that in the next part?
Yes.
I thought so. All right, we can come back to that question if it's not answered at the end. And I think we'll come back to those questions at the end too. So I think we're good. Actually though, Abby, while we have you on camera again, could you show everybody the pit tag again?
Oh, yes. So all right, I'm gonna try to do it against my hand. So there's the pit tag. Yeah, very small. So they come in different sizes. They come even smaller than this, but this is a 32 millimeter one, which is a good size for a river herring based on previous study done at the Conti lab.
Awesome. I do have one more question from earlier in the chat here. What does it mean for the species to have an easier migration that can potentially be achieved following dam removal, so that a longer term monitoring would be interesting or informative?
Can you, or let's see, I'm gonna try and write myself a note. I feel like that would be a good one to address after I show you the after data.
Okay.
But yes, good question. We can answer that.
All righty.
Chat.
All right, should I continue?
Oh, you just typed the message in.
Yes.
Okay. All right, on to
Thank
after
you for
dam
the
removal.
questions, everybody.
Yeah, thank you. Okay, so I'm going to show you some photos that Town of Plymouth had taken via drone of the construction process. And there's a whole set of these on the Department of Marine and Environmental Affairs Town of Plymouth website. So keep an eye on this yellow star, because the photos are taken from slightly different perspectives, so that'll help you get oriented. So here's the dam, and then on the left, you can see there's that Daniil fish ladder that used to get the fish up. They have now breached the dam, and the mill pond is starting to drain. They've taken out most of the fish ladder here. this is where Newfield Street eventually will go back to. And here is where the dam used to be. And then the river is starting to look a little bit more like a river. So just because the dam is taken out doesn't mean that the elevation goes away. The fish are swimming upstream. The reason the water is moving down towards the ocean is because there's an incline. So there's still elevation that fish have to swim over. You don't want them to encounter that elevation all at once, like in a waterfall. So what you do, same idea with the fish ladders, you break it up into smaller steps so that they're just moving up in small increments. So that's what's going on here, these weirs that are very specifically designed and put in places for very specific reasons. And then now, so the dam is right here. Here's the new skate park. And now we've got a river. So now I'm going to show you from the fish's point of view. So this is antenna 2 in 2018. This is now where antenna 2 is after the dam was removed. Antenna 3 was at the beginning of the Daniil fish ladder. And then after the dam is removed, antenna 3 is here, and we're looking upstream at this point. So someone asked about trying to hold things constant. So we did our best to put the antennas in the same place, the same spot that they were before the dam was removed. And we did that through GPS, but the GPS didn't quite have enough resolution, and so we also did it by looking at landmarks around us and trying to line them up. So we collected a bunch of data and took photographs before the dam was removed so that we could try and line them up in the same way. So here is our experimental setup, our set of antennas for after the dam was removed. So antenna 2, so let's see, we're looking, the water is flowing from right to left. Fish are going from left to right on the upstream migration. So antenna 2 is the beginning of the steep pass fish ladder. 3 was the beginning of the Daniil fish ladder. 4, 5, and 6 are within the Daniil. And antenna 7 corresponds to the top of the dam. So there's the dam right there. And this is where the fish would have swam out into the mill pond. So now I'm going to show you the after data and direct comparison to the before data. So I'm going to give you the numbers up here. So up here is your metrics. So we're going to start with attraction efficiency. I've got the numbers. This black line here represents 100% of tagged fish, and these arrows are a visual representation of these numbers. So for attraction efficiency, there was an improvement. It wasn't too bad before, 89%, but then after it was 98%. And so in the bottom right corner, I've got those numbers of fish. And so you can see that the number that approached and then the number that actually made it through. So this is looking underneath Newfield Street. So this was a statistically significant improvement, only slight, but heading in the right direction. Here's the favorite part of my data. This is the most dramatic. So we went from 25% passage to 92%. So this, we are looking at a slightly different view than before, but so we had 386 fish began, and then I forget my number and I can't see it because it's behind the video, but that number in the yellow box made it up to the top. So huge improvement in percent passage.
354 was the number.
Thank you. So, and then now here's the attempts. So these are for successful fish, the ones that made it up to the top. So you used to have between 1 and 9. Now we have between 1 and 4. And this kind of gets to someone's question earlier. The reason this is important is because if a fish is spending a lot of time trying, that's considered migratory delay. So they're spending time trying to get upstream when they should just be on their way up to the spawning pond. And if you're delayed like that, trying to get up a fish ladder, you are more apt to be eaten by a raccoon or a heron, you know, something like that. Or just get tired out before you get a chance to spawn. So an improvement in number of attempts. And then this was the hardest one to show you without like overwhelming you with figures. But the biggest takeaway here, I think, for transit time is before we were measuring it in hours, and after we're measuring it in minutes. So the average time before was 4.12 hours. The average after the dam removal is under an hour. It was 53 minutes. And actually, it's even easier to look at this transit time in minutes rather than hours. 60 minutes right there is an hour. So you can see most of the fish are getting through in under an hour. And then it sort of tapers off. Again, I show you this figure to show that like not all fish do things the same way. There's definitely a range in how they do things, different abilities, different environmental conditions. So those antennas that I showed you were not the only antennas that we put on the river. We also put an antenna in 2019, we put an antenna at the mouth of the river at Brewster Gardens underneath the pedestrian bridge. We had 6 antennas at the Jenny Grist Mill to try and figure out what's happening with fish passage there. There's the 7 antennas at Newfield Street. We also put an antenna just below the Boy Scout Bridge to see how long it took them to get through that mill pond that was created by Holmes Dam. And then we also put one up at Morton Park, so to see how long it took them to get up to Billington Sea. So we considered if fish got this far, then pretty darn good chance they were going to make it all the way up to the pond. So our other question, so those antennas allowed us, or the Morton Park antenna allowed us to answer the second part of our study question: did they get to the spawning pond easier after dam removal? So before dam removal, just a little over 22% were making it up. So of the fish that tried to get past the dam, only 22% made it. After, it was a little over 82%, so an improvement there as well. So then, because we put all those other antennas there, we got sort of what I was calling like bonus data. So we were able to collect a whole bunch of information about river herring life history and natural history that can just add to our understanding of the species. So one of the other questions we were able to ask is, how much time did they spend in Billington Sea? How much time are they spending there spawning? So Nate Christofori and Mike Cahill at Department of Marine Environmental Affairs with Plymouth are helping analyze the data. So we'll all be writing this journal article together. So this is a figure that Nate made. And so on the bottom here is the date that the fish arrived in Billington Sea. So it goes from April 30th to May 30th. And on the side is the number of days that they stayed in the pond. Pink circles mean female herring. The bigger the circle, it means the more herring did that same thing. And blue circles are males. And so what Nate found out looking at the data is that fish stayed between about 2 days and I think it was 24 days in the spawning pond. This is data that we don't really have much data on this. Yeah, there are a couple of other rivers that have data, but this is a contribution to the understanding of how long river herring are staying in fresh water. Nate also found that the earlier a fish arrived in the pond, the longer it stayed in there. If you got to the pond a little bit later, then your duration of stay in the pond was pretty quick. And that makes sense because they're being triggered by temperature. So if you're a late arrival, you only have a few days before the temperature of the water gets too hot and gives you the signal to head back out to the ocean. So Nate and Mike so Mike is analyzing data about the mill pond. So we're still working on that. Next year, we'll give you updates on that. Some of the other bonus data that we were able to get was on repeat spawners. And we had an inkling that maybe we would catch, or we would detect fish that we had tagged the year before, but we did not realize how many we would. And when we saw the first one come in the river, we were just so excited. So these are fish that were tagged in 2018. They survived the ocean, came back to the same river they were born in, and came back in 2019. So we detected 74 of those, and that was 14.8% of those tagged. So this is also an important contribution to just our understanding about how many fish do come back to spawn. Because they are different than salmon. So Pacific salmon will spawn once and die, river herring can spawn multiple times. They can come back to the river and spawn again. And so when you think of all those mouths out in the ocean that could eat them, the fact that they survived and made it back to our river is just amazing to me. We could also look, so here's a map of Town Brook as a whole. So here's Plymouth Harbor, and here's Billington Sea or freshwater lake. Because we had the antennas at the mouth of the river and then up here, we could look, and we had return fish, we could look at the total time they spent in fresh water. We detected 74 fish. There were only 17 fish that we had a full record. So we detected them when they came upstream. We detected them up here. We detected them when they went back. You know, pit tag antennas are very finicky, so that they don't work all the time. So often you miss fish. So of these 17 fish that we had a full record of, we know that they spent between 20 and 32 days in fresh water before heading back out to the ocean. So I just have a few more slides. I also wanted to let you know that we're doing before and after dam removal analysis, but there's also a bunch of other sort of study questions that we're working on at the same time. So we also put antennas at the Jenny Gristmill Steep Pass fish ladder 2 years in a row. And so I'm working on a report to the town of Plymouth on the passage issues there so that they can figure out how to get more fish upstream. We also tried to do outreach as much as possible. So these are the town of Plymouth recreation department kids that we did a program, an April vacation. So they are helping test out the antennas to see if they're working. We also brought lots of school field trips through from both the Plymouth school systems and surrounding towns. We even had a school from New Hampshire come. We also did classroom visits. And then my colleague, Grace Simpkins, and I have been working on some lesson plans for river herring. And so for both elementary school, middle school, and high school. So for the elementary school, it'll be based on natural history of river herring. Middle school, we're gonna take this, this actual data from the river in their neighborhood and have them map the tracks of the fish, both before and after dam removal. And work on some mapping skills and some quantitative skills. And then for high school, we're focusing this lesson on the students at the technical high schools. So this is basically a pit tag system in a box. So we will bring this to their classroom, have them put together different size antennas, and then see how that affects the detection range, so they can learn about the electromagnetism principles behind radio frequency identification. And then there was 2020. So we were planning on tagging another 500 fish this year because the last year, the restoration project wasn't quite finished. They had to stop halfway through the restoration and to let the fish up, and then they finished it afterwards. So we wanted to do another spring of evaluation when the whole river had been restored. We decided not to tag this year. You saw how many people are needed to tag herring. We just didn't think we could do it safely, so we chose not to tag. However, we did manage to get in the 7 antennas along Newfield Street where Holmes Dam used to be, also at Brewster Gardens at the mouth of the river, and also at Morton Park, where we would normally download data every single day. The Department of Marine Environmental Affairs guys are out there downloading data once a week and then keeping an eye on the antennas. Thankfully, I'm so thankful, grateful to them for doing that. So what we figured, what we were banking on, is that we'd put the antennas in there and that we would get repeat spawners again. That was our hope. And so collect some data from fish that had spent some time in the ocean and then come back. So if you're interested in keeping tabs on this on the Department of Marine Environmental Affairs website, I'm posting, I get weekly updates to Krista Lewis, and then she's posting them on the website with the numbers of fish. So here is the latest. Mike Cahill did get me data from today, but I didn't have time to analyze it before this talk. So this is the update as of May 13th. So at Brewster Gardens, at the mouth of the river, we have detected 160 river herring, again, that survived all those mouths that can eat them in the ocean and came back to the same river. Most of those were tagged in 2019, but we had 13% of them that were tagged in 2018. Through the Newfield Street, former Holmes Dam stretch, 119 of those river herring were detected, and all except for one made it through that section. So that's close to 100% passage right now. The antenna up at Morton Park, Billington Sea, we've detected 85 river herring up there. Again, most of those were tagged in 2019, but a few tagged in 2018. And we're starting to see downrunners now. So 38 fish I've seen at Brewster Gardens. They spent between 10 and 30 days in fresh water in Town Brook. So that includes both the river and the spawning pond. And they're heading downstream now. So just to review, did the removal of Holmes Dam improve the passage of river herring through the restored section of the river? Yes, it did. We went from 25% passage to 92% passage. And then did it improve them all the way up, to improve passage all the way up to the spawning pond at Billington Sea? Yes, yes, it did. So the answer is it did improve. The next step is that we want to make sure that all of those adults getting upstream lay their eggs, and that there are good conditions for juvenile herring to then swim back downstream and get to the ocean. And there was some research that was funded research through Sea Grant, actually. Some researchers from University of Massachusetts Amherst have figured out excellent ways to capture juvenile herring and look at their growth over the year, or for the summer, and then look at when they're leaving. That was going to happen this summer, but unfortunately that has been delayed because of COVID-19 as well. But we'll get back there out in the field, and so we will start asking some fun science questions about juveniles as well. So I just want to thank everybody that came out to help tag over the past years. It really, it takes a full team to do this. So I'm grateful for everyone helping over the years. And I thank you all for your time, and I'd be happy to take any questions.
Awesome. We have a couple questions in the chat, and then after we get those answered, we can actually hop back into the group view and talk in person. So this is a great question. What is the importance of these fish to the economy and the ecology?
To the economy and the ecology. So to the ecology, these fish are a really important food source for a lot of mammal species, other fish species, and bird species. So a lot of the fish that we like to eat, so like striped bass, bluefish, cod, they eat river herring. So we are tied up in that life cycle, or the food web with them. We humans do eat river herring. The Mashpee Wampanoag tribe, the Yaquina tribe, the Herring Pond tribe, still are allowed to harvest river herring. There's been a moratorium in place since 2006. Up until that moratorium, it was a very important part of the economy. Towns would actually auction off the rights to the fishery and then put that money in the town coffers. There are examples in the town of Wellfleet in the 1800s that they paid their town staff with the proceeds of the river herring. Times have changed, people's taste buds have changed. And so, I mean, I've eaten herring before. It's rough. There's a lot of bones in there. And then, yeah, so the economy, so it definitely supports recreational fishing, it supports commercial fishing, it supports tourism. A lot of people come to Plymouth in the spring to watch herring, and in a lot of the other towns as well.
Awesome.
I could talk for hours on that, but I'm going to stop there.
That's a loaded question. We could do a whole presentation on that.
Yes.
But thank you for asking. And we have a couple more here. So this is a great one. What is the mortality due to tagging, and is it considered in the success rates?
So we do have a study on that. I wish I had the numbers in front of me, but at the Conti lab, where they have controlled situations, so they could tag fish and then put them in these holding ponds that they have called Burrows ponds, and then look at the mortality over days. And I don't remember the exact numbers, but the mortality was very low, and within a range that was considered acceptable by fisheries biologists. Absolutely, you want to make sure that you are not negatively impacting your study species, and so that's why pit tagging is There's lots of different ways you can tag fish, but because the pit tags are so small, it's because they don't need a battery like a radio tag or an acoustic tag would. And so they're much, much smaller, which means, you know, it's less invasive for the herring to be tagged. And that was why it was great to see repeat spawners coming back too, because that's another indication that they're still able to live and thrive. Was there some mortality through this tagging process? Yeah, definitely there was. We tried to minimize that by doing it very quickly. That's why we have so many people there doing this, so that we can get the fish out of the water and then back into the water as quickly as possible. But low mortality.
Awesome. All right, so we have plenty more questions to get to here in the chat, but it is 8 o'clock. So what I want to do is we'll jump off the screen share, Abby. We'll go back into our little meeting so we can see each other.
Stop share.
And again, if you don't want to be on video, that's fine. But if you want to come back onto video, we're here. And at the top right of your screen, you can actually go into gallery view, which is what I prefer. And then you can kind of see everybody who's on the call. So we are going to get to some questions. If you do need to go, I know it's 8 o'clock and we totally understand if you have, you know, lots of exciting places to be. But we will stick around and answer the rest of the questions for those who would like to stay on the call. And I just want to say on behalf of Wildlands Trust, thank you for coming to our 3rd virtual program. That went off without a hitch, I would say. Thank you very much.
Knock on wood, knock on wood, we're not done yet.
Besides my computer crashing at the beginning. And our next one is next Thursday at 2 o'clock. It'll be an afternoon program with our county entomologist, Blake Dinius. He's going to be talking about tick and mosquito safety, very important stuff. So please join us. These programs do fill. So if you want to join us live, you can register on the Wildlands Trust website. And if you want to watch the recording later, that's fine too. They'll be up on the Wildlands Trust website as well. I will send everybody a follow-up email, and I'm going to send Abby some of those websites and links that you mentioned. We'll send that in the follow-up email so people can keep track on the town website and Sea Grant. But yeah, at this point, I'll address some of the other questions in the chat. And then if anybody wants to ask a question live, you can go to the participants tab and raise your hand, and I will call on you in just a moment. There are
So
some
nice
really
to
good
see everyone.
questions in the chat here.
Hi, Molly.
People wanted to know, there was like kind of a 2-part question that came in from 2 different people, which was neat. How long the Town Brook is, and then at what point the water turns brackish.
Town Brook is 1.6 miles long, and salt water does get up as far as underneath the Brewster Gardens Bridge. And we know that because we started getting really low detections for a little while, and Mike Cahill was trying to figure it out. So it would be, the tags wouldn't read, and then a couple hours later they were, and we could only figure that it was because it was salty. So the technology does not work as well when the water is salty. So it wasn't working well when it was salty, and then it was working better when it was fresh, is our going theory. So I think that's about as far as saltwater gets.
All right.
Looking at David Gould's head, I think he nodded during that.
He's nodding, yeah. Molly wants to know how many years you have worked at Sea Grant, Abby.
How many years have I worked at Sea Grant? I think it is now 7 years I have worked at Sea Grant. And before that, I was still working on Cape Cod, and I was working on fish passage restoration projects with the Cape Cod Conservation District.
Okay. Let's see, Jerry wants to know, has the moratorium on river herring resulted in a noticeable increase in game fish for the commercial fishermen?
Good question. I don't know that. There is lots of tracking of river herring populations. Many of you are probably involved with the volunteer river herring count programs, and that data is so important. And so in some rivers, you know, the populations are increasing. Some rivers, they're staying about the same, and some rivers, they're going down. It's really variable. But yeah, for so long, there were so many river herring in the river, why would you bother counting them? So like our data sets are not that long. We've really only been keeping track of the numbers of herring for about 10 years or so. The longest data set we have in the state is from the 1980s, and that's from Monument River and Bourne.
All righty. Kind of last question here in the chat, and then we have a raised hand that I'll get to. What percentage of fish make it up the fish ladder at the Jenny Gristmill?
Jenny Gristmill, we could have given a whole talk just on Jenny Gristmill. It's somewhere between, so we have like 3 different estimates. We have the 2018 data, we have the 2019 data, and then we have the return fish data. And so it's somewhere between 60 and 72% of the fish are making it up. And we found, or are making it up the fish ladder. And we did find some interesting things there. They are moving through the fish ladder itself pretty quickly and at the same amount of time as other studies have shown in the Conti Lab and at some of the other places. But then we think where they're getting stuck is that culvert underneath the road. So we don't really know why. It's dark, it's scary in there. The velocities might be different. So a little robot was sent through earlier this spring to try and figure out if there was anything in there. And it did find some tree roots. And they did cut those out, and we were so excited to evaluate this year to see if it would make a difference, but we didn't get those antennas up. So, but visually, I didn't get a chance to go to the river much this year, but I'm very curious to hear if folks think they got through easier this year or not, just by looking. And of course, we have the video camera up at the top of Jenny Gristmill as well, so that's another way we can track passage through. Sorry, I'll try and give shorter answers now. As you can tell, I could talk about river herring all night. So.
People are on voluntarily at this point. All right, so we have a question that's going to be in person. I'm going to unmute you guys, Sarah and Molly. Go ahead. As soon as.
Hi, Sarah. Hi, Molly.
Hello.
Do you have any other favorite kinds of fishes?
Do I have any other favorite kinds of fishes? So my favorite type of fish are the ones that can go back and forth between salt and fresh water. So I think my second favorite fish are eels, American eels, and then my third favorite fish are rainbow smelt.
No love for the shad, I guess.
Top 3, There's only like 160 species, I think, of anadromous fish. So somebody's going to be at the bottom.
Favorite sea creature.
Favorite sea creature? River herring.
Yeah. Thanks.
I'm a polar bear.
Thanks, Molly.
There's a few more in the chat now. I think you answered this already, but how many fish made it to Billington Sea this year from the
I think the number is, as of last week, 85. It could have been more than that because, again, we're not out there every day checking on the antennas. Like we would have if we were doing a full study this year. So the antennas might have been finicky. So we'll see. So 85 so far, and it might be a little bit more than that.
We actually have another raised hand here. Robin, I'm going to unmute you. I keep saying that and then it's not working. Robin, you can hop off mute and ask your question.
Okay. So my husband was watching and he wrote down, if you have any information about shad in the Eel River. No.
I do not have any information. Can David hop on?
We live right by the Eel River, actually Eel River Circle.
Yeah, no shad in Eel River, but I will say that this year has been one of the better years for the herring run in Eel River. Several years ago, the town and Division of Marine Fisheries transported fish actually from Town Brook to improve that run, and I think we're starting finally to see the results of that this year.
Also,
So
Rachel, I saw there's a question. Are there any other dam removals planned in the area? Can Sarah Grady answer that question?
Yes. We're going to take them all out. No, the next dam removal that's likely to happen on the South Shore is going to be Peterson Pond Dam, which is the third dam upstream, or now it's the first dam, but it was formerly the third dam upstream on the Third Herring Brook. It's right behind the Hanover Mall.
The
Actually,
Hanover Mall is getting destroyed.
and the Hanover, yeah, yes. And
Isn't it a new thing? It was
Right.
supposed to come this year, but it can't.
right. Well, so yeah, so we're somewhat racing the Hanover Mall and their project, and working with them to take out Peterson Pond Dam, and then hopefully we'll have fish passage at Dick's Pond, which is right on Route 123, and you can come and see the herring there too.
Actually, there'll also be two dam removals starting in Plymouth starting next week. At the Foothills Preserve in the Tidmarsh Sanctuary, we'll be starting a project to restore former cranberry bogs to wetlands, and there's 2 dams on the downstream side that will be removed this summer.
There you go, 3 dam removals just this summer.
Ooh, that's awesome. When does the run end each year?
So it's a little variable. So we're starting to see down runners now. So this is the point in time in the year that I like to, so there are fish still coming upstream, but then there are fish that have spawned earlier in the season coming downstream. And so I like to imagine the down runners giving the little up runners like little high fives as they go by. And so that'll sort of be, switching up pretty soon, and it'll be mostly down runners. And when you go and look in the river, you can tell that they're down runners because the fish, they just look tired. They look a little bit beat up, and oftentimes you'll see some fungal growths on them. And when they do get out to salt water, that will go away and they'll get better. But you can tell the difference between up runners and down runners these days. Maybe that's another question for David. When it's usually like by early June, things are pretty much wrapped up, or is it before then?
Yeah, it's usually around the 3rd week of May. So we've already starting to see a decrease, and as Abby mentioned, definitely seeing a lot of down runners, especially the last few days.
All right. Julia wants to know, how many fish do you think that the Jenny raccoons eat?
So I had a video I almost included in this. I don't know percentage wise. At some day it might be fun to put in a wildlife camera up at the top and just try and quantify that. But yeah, those are very healthy looking raccoons at Jenny Gristmill. They have beautiful coats.
We have another raised hand from Sarah and Molly.
Yeah. Oh,
sorry.
we're playing the mute game.
Yep.
No, I just wanted, as a comment, which is that sort of on a broader scale, with all of the herring runs in the area, that the ones that are, Abby mentioned that this is mostly an alewife run, but the more blueback dominated runs, they come in when the water temperature is a little bit warmer. So those runs actually also go longer. So for example, South River and Marshfield, there are herring going through mid-June.
I think that is all of the questions in the chat. I think we've gotten to all of them, but if we haven't, and if I missed you and you can't figure out the hand raise feature, that happens sometimes, feel free to hop off mute and ask a question if you have it now. Nope, we got Jerry coming off mute now to ask your question, hopefully. It's not letting me do it, I don't know why. Jerry, you guys can unmute yourself. There you go, perfect.
I'm just wondering this year whether, because it was a milder winter, we normally count here at Sandy Brook Run in Sandy Brook Bridge on the monument, Herring River. But this year we weren't counting because of the COVID-19. But I'm wondering, did they start earlier this year? Because it seemed like the water wasn't as cold coming out of the pond. We didn't freeze this year.
I know in the Cape Cod runs, it was a really weird year because it was a mild winter, but then it was also a cold spring.
It was, yeah.
And they would come through in fits and starts. And when we'd have a sunny day, lots of fish would come through. And then as soon as the temperature went down, the herring would stop. So yeah, which is the value in having those counts. And this year was difficult. Most programs decided, some programs where you could, be pretty reasonably sure that you could social distance and not have anyone else around. They did continue. but most programs decided not to count. So we'll get data this year from the places that have video cameras. So Plymouth, Mystic River in Boston, Pembroke, Herring River and Harwich. So we'll be able to answer some of those questions later once we compile all the data.
Abby, do you think you're going to be able to get some more money because you've shown results? Are you actively pursuing that?
So we would like, I mean, there's no shortage of things to study. This year we had plans. We were also going to look at straying because it's pretty well established for Pacific salmon species that a certain percentage of them don't go back to their same home river, that they stray off into other places, other nearby rivers. And so that's how new populations would have gotten started, genetic mixing. And so we were curious if that was happening with river herring, and we thought with all these tags in the water, we wanted to get as much data as we could from them as possible. So I had worked with Jones River Watershed Association and then Town of Plymouth. We were going to put antennas up at Eel River and then also Jones River to see if we were getting any straying. And then we just had to shrink the project. So I'm hoping to do that next year. Town of Plymouth already purchased tags for next year. We would still like to, or they purchased tags for this year, but we have them available. So we would like to do one more year. And I think we have an opportunity to revise some of our study questions too. So yes, definitely, we will be looking for funding to do another year of tagging.
You think it might be useful to see to quantify how effective it is to transfer herring from one source river to another to seed it, so to speak, because that has implications for a lot of different areas and a lot of different herring.
Yeah, and it could, so if we can show, we don't know, but if we can show that a certain percentage are straying, then that helps make the case for restoration too. So you're not just improving just like you said, so you're not improving the population just in that one river, but that you're benefiting the region as a whole.
Have you prioritized what you want to do next? I'm done.
We finish this season first. We're still collecting data. Yeah, and then as soon as we take down the equipment, and I've got all my data backed up in multiple locations, so I'm darn sure that it's not going to go away. Yeah, then we'll start talking about next season.
You should ask David if he's going to get any money for dam removal, more money for dam removal.
We can hear you. What do you want to ask David?
I wanted to ask David if he thinks he, showing with Abby's data whether we would get more money for dam removal for that, because this has shown such great progress.
That's a great question, and Abby mentioned back in 2008, 2009 when we did the study of the Billington Street. What that data showed was that the project was successful, but that the fish then couldn't get up to the next two dams which were off Billington Street and Plimco, and that data was absolutely critical to allowing us to get funding to remove those two upstream dams. And so the hope is that we can use some of the data that we're collecting right now on passage at Jenny Gristmill to acquire funding to construct a bypass around that mill building and improve passage that way. So hoping to sort of replicate the success of and use of that data again.
Great.
Would anybody else like to hop off mute and ask a question? All right, Carlos?
Yeah, have you been finding good results with the eels, Dave?
Dave, you're on mute.
Dave, you're on mute.
This year was really interesting when it came to eels. So last year, both eels and river herring were running concurrently. We've only started seeing significant number of eels within the last week. So pretty much every day this week, we've had about 1,000 eels in the eel trap, but much later than last year. So that's pretty interesting data so far. So the eel run this year is running much later than the herring run.
Okay, thanks. I also had a comment for Abigail. You'd mentioned about some herring run counts. I know Middleborough's doing them because I've gone up to Middleborough and I watched counters a couple of times. So they're still running there. That's good. So, and I'm doing the counts with my daughter, so we wear our masks. So we, She does it obviously 10 minutes after I finish, but I usually start first. But still seeing some, not many this year though. I come on Sundays in the morning. I've seen, you know, the most 24. Not a lot. That's it.
Thanks, Carlos. Anybody else want to hop in?
Yeah, this is Eric. Well, actually, Julia, but I have one comment. Besides that being a fantastic presentation, for all you fish counters on here, in case any of you haven't taken the opportunity, you can still do fish counts from the convenience of your computer at home in Town Brook. For those of you who don't know that, the opportunity is there to do fish counts on your computer with clips that are taken and posted online, which is helping Dave Gould out and Abby figure out what's going on in Town Brook. And some of those fish that you're counting will actually be tagged, but you won't know which ones.
We had tagged what we call dignitary fish during the Earth Day event last year. So we assigned a fish to the governor, Commissioner Amadon, and we were really hoping we would see some of those dignitary fish this year, but I haven't seen them yet. There's still a little bit of time, possibly. But when Rachel sends out the link with, or the email with all the links in it, we can add that into for counting online.
But feel good if those fish do not come back, because they may have fed a codfish,
right,
or a tuna fish that are working out there. So there's no loss to a fish being missed, even if it was the governor of Massachusetts. His fish fed another fish.
Good point, Eric. Thank you.
And just to follow up on Eric's point there is, if anybody knows any friends or relatives in South Dakota, let them know to do a herring count for us, because it's the only state we don't have a herring count from. So we have every state in the union except for South Dakota, and we have over 33 countries around the world that have done counts for us this year.
34, not 33.
I think one of our yoga instructors is from South Dakota. I'll see if she has any family out there for you.
Excellent.
All right. Well, thank you all so much. Thank you, Abigail Archer, for a wonderful presentation. There were a lot of great comments in the chat saying thank you and that it was wonderful and great information. We're very grateful for you doing this for Wildlands Trust. And thank you to our partners, to the Woods Hole Sea Grant, to NOAA, to the town of Plymouth. Thank you, David. Eric, good to see you, / Julia. And it's great to see a lot of familiar faces. I love these. I feel like we get a little bit more connected when we log in here. So thank you all for joining us tonight. And hopefully we'll see you at the next one, or maybe even in person. Who knows?
Great presentation. Thank you.
Thank you,
Thank
Sam.
you very much.
Thank you, Abigail.
Bye, everyone. It's so nice to see your faces. Thank you for coming tonight.
Great job, Abby.
Thank you.